Okay, so 8.5 is on sine and cosine. We already talked about tangent. These are the other two trig ratios that you need to know. It's not that different than what we talked about as far as the basics, but I want to go through and explain it. So first of all, sine, here's the word. Here's the abbreviation for it. Please don't call it sin, it's sine. Whether it's written this way or this way, it is sine. It's the ratio that uses an acute angle, a leg of the right triangle, and the hypotenuse. What you need to know is this formula. So sine is the leg opposite over the hypotenuse. Remember tangent that we already learned? The tangent is opposite over adjacent. This is a different kind of ratio. Looking at my picture, if you're doing the sine of angle A, it's the leg opposite angle A over the hypotenuse. Be careful that you're picking the leg opposite and the hypotenuse to make a proper ratio. We also did this with tangent. So this is an example. It says find the sine of R and the sine of S, write it as a reduced fraction and a decimal rounded to the 4 places. So we're gonna do the sine of R first. So using our formula, here's angle R. The leg opposite R is 15 and the hypotenuse is 25. Always, always reduce. Divide both by 5 and you get 3/5 as your reduced fraction. When we plug this into our calculator, the decimal is 0.6. Nothing to round, it's just plain 0.6. Let's do the sine of S. Again, it only can be the acute angles. You'll never find sine, cosine, or tangent of the 90-degree angle. Sine of S, the opposite side is 20. The opposite is 20. The hypotenuse is 25. Again, we're going to reduce it, divide by 5, and I get 4/5. When you put this into your calculator, your answer is 0.8. All this is doing is showing you a relationship between the two side lengths. So what I'd be looking for in a test or a quiz is the reduced fraction, the decimal, in both scenarios. This is really nothing new, but understand what you're doing here is just expressing the ratio of the side lengths. Cosine, this is your third and final ratio that we'll talk about. This is the full word, this is the abbreviation. Again, it's not cost, it's always cosine. We're still talking about an acute angle, but the cosine is the leg adjacent over the hypotenuse. So if you look at the picture, the cosine of angle A is an acute angle, is the leg adjacent to it over the hypotenuse. So these are the two legs. This is the leg that's adjacent, this one's the opposite. Leg adjacent over the hypotenuse. This is what you need to memorize. So cosine is adjacent over hypotenuse. Very similar to what I did with the last example, we're going to find the cosine of angle A. So cosine of angle A is the leg adjacent. This is the leg that's adjacent, 48. The hypotenuse is 52. And we need to reduce that, so if we divide the top and the bottom by 2, we end up with 12/13. This is my reduced fraction. When you put this in your calculator, 48 divided by 52, or even 12 divided by 13, your rounded decimal is 0.9231. Be careful with your rounding, 4 decimal places. We'll also do cosine of B. Here's angle B. The adjacent leg is 20. The hypotenuse is 52. Again, we need to reduce. So if we divide everything by 4, 20 divided by 4 gives me 5. 52 divided by 4 gives me 13. This is my reduced fraction. Top divided by bottom in either scenario will give you the same answer, which is 0.3846. So this is very similar to what we've been doing. We're asking for the ratio or the fraction and the decimal, which shows the relationship of the sides. Up front, we're going to use our formulas to figure out the unknown values of the sides. Again, these are another example of only being able to use trig to do these kinds of problems. So looking at our examples here, I see I'm given the hypotenuse. I'm given 50. Now there's a couple ways you can do this, so I'm going to explain it using sine and cosine. I'm going to find A first. So because I'm using the side that's adjacent to 50 and the hypotenuse, I'm going to use cosine. So I'm going to set this up just like we did with these problems in the front of the room for tangent. So cosine of 50, leg adjacent is A. The hypotenuse is 10. So just like we did with tangent, we're going to go through those equation solving. To get a by itself, I'm going to get rid of that 10, so I'm going to multiply both sides by 10. So on the left, I have 10 times the cosine of 50 equals a. This is what you're plugging into Desmos. Remember, you need to double check that it is in degrees, which I showed you how to do last block. So when you plug this in, when I round, and I'm rounding to the 10th place, I have 6.4 as a. Now that I know that, I can plug it in and use it as my next step. I'm not going to do that though. To find b in relation to 50 degrees, this is my opposite side, and I know my hypotenuse. So I'm going to use my sine function. The sine of 50, opposite 50 is b. The hypotenuse is 10. Again, I can't emphasize enough, you can do this in lots of different ways. You can even use the Pythagorean theorem at this point. We can do that next block. At this point, I want you to be practicing sine and cosine ideas. So I need to get b by itself. I'm going to multiply both sides by 10 to get that b by itself. On the left, I have 10 times the sine of 50. On the right is just b. This is what you plug into your calculator. And when you do that, you end up with 7.7 as your rounded decimal. So these are the two unknown sides that I was asked to find. The next one, number 4, same idea. We're being asked to find the value of m and the value of n. So in this case, we're given one of the legs. We have to figure out the other leg and the hypotenuse. So the first thing I'm going to do is just kind of wrap my head around what I can use. I could use tangent, but we're not doing tangent today. We're going to just use sine and cosine. I'm going to use 39, and if I do the opposite leg and the hypotenuse, there's one unknown number, which is the hypotenuse. So I can use my sine function. So if I do the sine of 39, opposite leg is 25, the hypotenuse is n. Remember, there's 3 unknowns when you use these formulas. The angle and the 2 sides. Right now, I want you to be able to set it up to figure out either of the sides. Eventually, we'll go back and we'll find the angle measurement next block. So to solve this, we're going to get the n out of the denominator first. On the left, I have n times the sine of 39 equals 25, because these n's cancel out. On the left, I'm going to divide by the sine of 39. The sine of 39's cancel. This is what you put in your calculator. 25 divided by the sine of 39, which gives me 39.7. So now that I know 39.7, I can use that for my next step. So for m, I can use my cosine function because m is my adjacent side and this is my hypotenuse. So there's only one unknown. So I'm going to write this up as cosine of 39. Cosine of 39 is adjacent side over the hypotenuse. So that's going to be m over 39.7. I'm going to multiply both sides by 39.7 to get that m by itself. These cancel. So this is what I'm putting in my calculator to figure out what m is. And when you do that, you should get 30.9 as m. So the biggest things I want you to be able to understand is being able to set up equations to solve for an unknown side only, and be able to write equations or ratios and rounded decimals using sine and cosine. And if you have questions, I'll see you guys soon and answer any questions you have.